Good morning. Let us see today thermodynamics, the fundamental concepts, what are extensive properties and intensive properties, what are the differences between exact differential, inexact differential, and we will derive the Euler Reciprocal relationship. This is very important when we study chemical potential. When we study chemical potential in thermodynamics, that is important in deriving Gibbs absorption isotherm and other etc. and cyclic rule. Okay, first we will see what are extensive property. Extensive property of a thermodynamic system depends upon the amount of substance present in the system or the quantity of substance present in the system. Whereas intensive property does not depend on the quantity of substance present in the system. For example, volume, mass of the earth. Okay, so it depends upon the quantity, amount of mass, how much mass you have taken. You have taken less or more. Similarly, energy. If you burn fuel, if you burn 1 gram, you will get energy. If you burn 5 gram, you will get more energy. So similarly, enthalpy, change in free energy, change in enthalpy, etc. Whereas intensive properties are temperature. For example, temperature, to measure temperature of earth or temperature of Virudhunagar town or any place, then you keep the thermometer and you can measure the temperature. You need not take all temperature, all. Okay, so it does not depend upon the quantity of the substance present in the system. Pressure, similarly, and density. Density is also intensive property. It does not depend upon, for example, density of the ocean, density of the sea. You can just take 1 ml water and take weight, you can find density. Whereas mass and volume are extensive property. To find the mass of the ocean or sea, you need to take all the water and take mass, but it is not like that. To take density, you take 1 drop, 1 ml of water, you can measure the density. It does not depend upon the amount of the substance present in the system. When you take the ratio, it becomes intensive property. You see, these two are extensive property. When you take ratio, it becomes intensive property. Similarly, concentration, moles per liter. Concentration is expressed in moles per liter. Moles per liter, it is mole divided by liter, volume. Therefore, it becomes intensive property. Refractive index, surface tension, viscosity. Similarly, delta H is extensive property, whereas delta H per mole, heat of reaction per mole of the substance, is intensive property. Remember, free energy change per mole of the substance is intensive property, whereas free energy change itself is an extensive property. Now, what are state functions and path functions? For example, state functions are the important state functions in thermodynamic system are pressure, temperature, energy, internal energy, enthalpy, G. All the thermodynamic functions are state functions. And heat and work or W and Q are path functions. What is the difference? A change in, for example, a change in internal energy or a change in state function depends only on the initial state and final state, E1 and E2. Therefore, E2 minus E1. It does not depend on the path of the process by which the changes has occurred. Okay, it does not depend on the path of the process. Whereas path function depends only on the path of the process, path of the thermodynamic process, not on the initial and final states. For example, you are going from your home to college. Okay, then initial state is home and final state is your college. Okay, now if you are cycling, you are doing work, you can go straight. Then W1. Okay. Now, if you go long route, if you take long route, then it will be W2. So, W1 not equal to W1, the more work. W1 not equal to W2, therefore, you will do more work. It depends on the path, how you are going. Okay. So, this is what the thermodynamic function means. Now, the differential of energy, differential of enthalpy, the differential are called exact differential. The differential of state functions are exact differentials. The differentials of path functions are inexact differential. What does it mean? the exact differentials can be integrated between the limits. The exact differentials can be integrated between the limits, whereas if see integral dg or dE, energy of the state 1, energy of the state 2, E2 minus E1, similarly Q2 minus Q1, the energy of the state 1 Q1, this is the energy of the state Q2, not equal to Q2 minus Q1. Okay. Now let us see Euler Reciprocal relation. What is called Euler Reciprocal relationship? As I said, it is very important in studying chemical potential, in studying Gibbs adsorption isotherm. You will see in the next classes. So what is? Let us consider a state function Z. There are several state functions. Let us consider a general state function Z. It depends on two variables. For example, temperature and pressure. Here x and y. Let us call it as x and y. Now Z is a function of two variables x and y. Now the differential, the state functions are exact differentials. Therefore, dz for exact differential, it can be mathematically written like this. For exact differential of state function, it can be written like this. Therefore, dz equal to dou z by dou x y constant y dx plus dou z by dou y at constant x dy. Okay, this is equal to m x comma y. This is equal to, or we cannot define also, n x comma y. Therefore, dx dy dz. Let us take second derivative. Now you do here y is constant. Therefore, you differentiate again with respect to y. Okay, because you are varying both x and y. Now dou z by dou x. Okay, dou z by dou x and dou y. Therefore, that is dou m by dou y. This is already dou x. Therefore, dou y, dou z by dou x, dou y. Similarly, on taking double derivative by varying x also, dou z dou y into dou x, that is dou m by dou x y. Now these two are equal. These two are equal. Therefore, these two are equal, and this relationship is called Euler Reciprocal relationship. This relationship is called Euler Reciprocal relationship. Now let us see what is called cyclic rule. For a change in thermodynamic system occurs a constant Z. There is no change in the state function Z. There is no change in the value of the Z function. Okay. Now therefore dz equal to 0. E2 equal to E1. There is no change. Okay. So Z2 minus Z1 equal to 0. dz equal to 0. On substituting in the equation 1 equal to 0. Therefore you put 0 here. Then if you put 0 here, then you bring this left hand side and right hand side minus. Okay, so dou z by dou x and dou x equal to dou dx minus. Therefore, on next you dou z by dou x, you take dou y here, you bring it dou y here. Therefore, dou x by dou y a constant z. Okay, and then this you bring it here. Therefore, dou y, it will go up, dou y by dou z at constant x equal to -1. This is called a cyclic rule. This equation is called a cyclic rule. This is applicable for exact differential or state functions only. Okay, thank you for watching.